Muted. Good evening, everybody.
Jackie just realized, Jackie has been talking for 5 minutes and just realized you're muted.
Jackie's just talking away to me. Happy New Year!
Good evening, SPC gang. We, I guess, started off with a bang. We've got Jackie and Wade and Rachel here in Bozeman to go through the January webinar with you guys that's focused on animal breeding and genetics, and specifically on EPDs and selection indexes. We're going to cover a lot of ground tonight, but hoping that that you stay with us. So we've got a series of questions kind of sprinkled throughout this webinar to really try and drive home some points and some frequent misconceptions in regard to genetic evaluation. Hopefully everybody can hear me, and we are recording this, so I've got those details in place. So I like to start off by telling people I am this kind of animal breeder. My background is in reproductive physiology. I spent a lot of time wearing big sleeves and armpit deep with cattle, and really have learned a lot more about animal breeding and genetics since coming on with the ASA. But thankfully, Wade is this kind of animal breeder, and Wade can't see the entire slide set, so I'm just going to hide this a little bit. There's Wade sitting on his computer working numbers, and we all like to tease Wade, but actually Wade is uniquely suited. He's got a strong background, was a breeder both before and after going to graduate school and up until coming on staff with the American Simmental Association. So he's got a strong background in owning cattle, raising cattle, breeding cattle, showing cattle. He might not want you all to know this, but then also understands the statistics and methodology behind genetic evaluation. So it's really we're blessed to have somebody like that at the helm of this association. So tonight you're going to hear from both Wade and I. I'm going to set up some frequently misconceptions, I guess, and we'll hear some answers from Wade. So we're going to focus on EPDs and indexes, and I just wanted to take a minute to reflect on why this is important. The beef cattle genetics that you use today, if you are keeping replacements in your herd, could be around 15 years from now. And that's staggering, and it's worth considering and doing some homework. If I told you you're going to go out and buy a car today and you have to have that car 15 years from now, you would do some homework. You would study safety and mileage and all kinds of stuff in regards to different types of automobiles before you made that purchase. And I don't know that people always take that same studious approach to selecting their genetics, but it's powerful, and it has a lasting impression in your herd. In between the sires that you're using and the maternal grandsires in the cow herd, that accounts for 75% of the genetics in your herd. And again, it's kind of a staggering figure if you think about it. Those two generations of sires, they're 3/4 of the genetics in your operation. So it's worth studying, and it's worth trying to select the right one there. EPDs are 7 to 9 more times more effective in generating a response to selection than an actual measurement or a phenotype. They're 7 to 9 more times as likely to get you to where you want to go. And I think that's not always understood and important to hold on to as we talk through this. And then selection indexes are really designed to help you select for profit. There's a lot of traits that interact in opposing ways. You might want more growth, but in a cow herd, larger mature size isn't exactly an economically sustainable path. And so the nice thing with selection indexes is they calculate all of that together into one number, which is profit. And so we'll go through some of those things tonight. Can't get the to work. So the goals for tonight, I'd like to help you understand what a phenotype is and what influences a phenotype, what is heritability and how to use it, how to make sense of it. We'll define and learn how to use EPDs. We'll look at percentile rankings and where to find these. We'll cover accuracy and have some examples of how to kind of think through accuracy. We are going to briefly cover the use of genomics testing to increase accuracy of EPDs. We'll cover a tip of the iceberg with selection indexes, and like I said, along the way we're going to address some myths and frequently asked questions. So phenotype versus genotype. A phenotype is the observable characteristics of an animal. This might be weight, color, size, pregnant status, horn, polled, etc. Where the genotype is the genetic makeup of an individual. And so the phenotype is influenced by two things, basically, the genetics of the animal and their environment. So I like to use this as an example. So this young child here in the middle of the top picture, that's me rocking some earrings when I was, 7 years old or something. And I was very, very blonde. And I was genetically predisposed to being blonde. But as I've grown older, I use environmental influences to help change my phenotype. So I lighten my hair. And so there's things outside of my genetics. My genetics are telling my hair to get darker, and I help my hair stay lighter with environment. Heritability explains how much of the variation in the phenotype is explained by the genetics. And so it's the proportion of differences, phenotypic differences that are explained by genetics. Heritability ranges from 0 to 1, where highly heritable traits, genetics have a larger influence on the variation, and it's easier to make progress by selecting on a phenotype. In lowly heritable traits, the genetics have a smaller influence on the phenotype, and it's harder to make progress by selecting on the phenotype. So structural traits and carcass traits tend to be highly heritable, where traits associated with fertility are an example of more lowly heritable traits. So we've got the first question of the night from Dr. Shafer is to address whether or not it's true or false that because someone culls all their open cows, if that's an indication of making large progress in selecting for fertility in the cow herd.
So, Jackie, thank you for setting me up here. Anyway, by the way, I was born with dark hair, but I use coloring to make it gray. That's what I've been doing for years now. But anyway, so the first question that you need to answer this full question is fertility a highly or lowly heritable trait? And it turns out that fertility is a lowly heritable trait. And another way I like to differentiate between high and low heritability is with a high heritability trait, the saying, what you see is what you get, is pretty appropriate. With a lowly heritable trait, what you see is not necessarily what you get. And so the answer to this question, contrary to many producers' opinion, culling open cows does not improve your fertility, your genetic fertility, very much. If you're culling based on simply whether or not they're open or bred, you're not going to be making a lot of genetic progress. And the reason being is that with a lowly heritable trait, like I said, what you see is not necessarily what you get. And so if you're simply calling on what you see, whether they're pregnant or open, you're going to end up calling some animals that it might have tremendous genetics for fertility, but for whatever reason, non-genetic reason, they are open, and you're going to end up keeping animals that might not size up very well genetically for fertility, but they happen to be bred. So contrary to popular conventional wisdom, calling on pregnant or open is not going to get you very far. Now, I don't know what the next slide is, but the solution, and maybe Jackie's coming with the next slide here.
I'm not.
Oh,
I don't think I am.
The solution is, if the question becomes, then if I'm not making progress by simply culling open cows, or if I'm not making much progress, how do I do that? And that is to use EPDs. Use EPDs for fertility, and our IGS genetic evaluation, the EPD that gauges fertility is stability. So if you select for high stability sires, you are going to be increasing your herd's genetic fertility.
Thanks, Wade. So, Jackie's having technical difficulty tonight, but we had some people not able to see the screen, and hopefully everybody can see it now. So we'll put up these PowerPoint slides or make them available so you can see all the pretty pictures from the first part of the talk. So thank you, Wade. Yep, that's helpful. And just so you all know, we do have some EPDs associated with fertility. One is stability, and that's a cow staying in the herd for 6 years. The likelihood of that animal's progeny or daughters staying in the herd for 6 years. We're also developing another one, which is a heifer pregnancy EPD, and so those two would be very beneficial for selecting on fertility. Another thing that we didn't really address in this talk was crossbreeding is another great way to increase some of those traits that are lowly heritable. So we won't spend a lot of time on this, but some traits that you'll work with are simply inherited traits, and just a few genes, 1 or 2 genes, are controlling this phenotype of those traits. Typically, there is a dominant version and a recessive version of the genes involved. In the dominant case, that animal only needs 1 copy of that allele in order to display the trait. The dominant allele will mask the recessive allele or the recessive form of that gene. So with recessives, an animal needs 2 copies of the gene in order to display that condition. An example of this is coat color. The extension locus is the gene that we talked about that controls the inheritance of red or black coat color. There's actually lots of different genes if you get into the minutia, but the main gene that we talk about is the extension gene. Black is dominant to red, and so hopefully folks can see the screen now, and you can see that we've got a picture here of a red calf and a black calf. So if we have these 2 animals, we can look at this red calf and be pretty sure of the genotype, and that genotype would be little e, since it's a recessive form of that gene. The black animal, we cannot simply look at it in order to distinguish the genotype, because black is dominant. So those are animals that typically get tested for something like coat color, because we can't tell if they are homozygous black or heterozygous black. Unfortunately, or maybe for job security, fortunately, things get more complicated than these simple traits. So most of the traits that or all of the traits that we work with in the genetic evaluation are polygenic traits. So these are traits that have several, tens, hundreds of genes that are involved in the phenotype, and so instead of using a Punnett square or something to predict progeny outcome, we need to do something a bit more complicated, and that's develop EPDs, or expected progeny differences. So an EPD estimates the difference one could expect in the performance of progeny for a different trait, or for a specific trait between animals, and it's given in units for that trait. And we'll talk a little bit more about this, but it's a compilation of lots and lots of records. Eventually, sometimes initially in life, it's just an average of the parents. But as the animal gets more older, it gets its own records, and then gets progeny, all that information is fed into these EPD calculations, and that helps reduce the noise that's brought with environmental influences of phenotypes. So the ingredients of an EPD, we start off with pedigree information, that animal's individual performance is added, and later in life, progeny performance come in, and we also now have genomic predictions to help fine-tune the EPDs. And so really the gold mine is once we start getting progeny performance, that's when you start to see increased accuracy of EPDs. So if you think about EPDs, if you think about, pretend that we can zero in on an animal's chromosomes, and we've got two sets of genes for every chromosome for every animal. And some animals every animal is going to have genes that are positively associated with a trait and genes that are negatively associated with the trait. And here's an example of just some numeric values associated with DNA markers for a particular trait. Pick whatever trait you want that to be. Say it's weaning weight. So you would sum up all of the genetic influences that this animal has for weaning weight and divide it by 2, and that's what you would calculate as their EPD. So here we've got an example of 3 bulls. One bull, if you sum up all their numbers and divide them by 2, he's got an EPD of 5. Another bull has an EPD of -3, and then this bottom bull has an EPD of 1. So what we want you to see from this is even the bull with the best EPD here, he has some genetic components that are negative for that trait, if lower is bad. And even the bull with the EPD of 1, or excuse me, the bull with the EPD of -3, he's the worst bull in this example, but he too has some positive markers or DNA, positive genetics for that trait. And so, so it really depends on every offspring of that animal, whether or not they're going to get, all good genes, all bad genes, some combination of those genes. And so we have another question for Wade here. It's a question that we hear. We've got somebody who has a bull that had a high actual weaning weight, but he has a really low EPD for weaning weight. So how can this be, Wade? How can you have a poor or a good phenotype and not a very good EPD for that trait?
Yeah, so that scenario is not all that uncommon. First of all, we know, obviously, the same herd moved around the country, or exposed to different management practices, say creep-fed versus not, and so forth, or in an excellent pasture versus a parking lot, essentially, for grazing. There's going to the environment in those cases going to cause a big disparity in weaning weights. The same herd could have 200-300 pound differences or more in weaning weight depending on management, location, and all the environmental factors. So we certainly know that there are going to be some very high growth cattle genetically, that if they're in a rough environment, they're not able to express that growth. But because EPDs aren't based on actual growth, in other words, if you have an 800 pound weaning weight, we can't tell you what kind of an EPD that's going to be unless we know what the other animals in the contemporary group are and what kind of weaning weights they have. So with EPDs, EPDs are very contingent on the other contemporaries in the contemporary group. So if you have a contemporary group in a very poor growth area, or an area where you would expect low weaning weights, very easy to see that you can have an animal with a lot of genetic potential for growth, but it's not expressed. So that's kind of at the core of why it's not unusual to see animals with what we would consider poor phenotypes for a trait, in this case weaning weight, actually having a good genetic value, and we determine that through how they size up with their contemporaries. And even within a contemporary group, and all the cattle are perceived to be treated the same, they're in the same pastures and so forth, and they might all be exposed to creep feed. It's not unusual for animals that have lower weaning weights to actually have higher genetic predictions than other calves in that contemporary group. And the reason being, again, goes back to heritability. We know in a trait like weaning weight, we know that about 70 to 75% of the differences we see between weaning weight in a contemporary group is due to environment. Now, that sounds contradictory because I just told you they're all in the same contemporary group, so therefore we assume, well, they must have the same environment. No, they don't have the same environment. They're in the same contemporary group, but there still are many different environmental factors that we have no idea what they are, but they exist. We know they exist. Some obvious ones are the age of the dam. We know older dams milk more, so the calves are going to weigh more. Now that's one we know about, and we can make an adjustment for it. But there are still many other environmental factors we can't adjust for, and that's why even within a contemporary group, it's not unusual to see an animal that might not have a shiny phenotype that still is predicted to have a strong genotype, and that's based on all the information we're able to collect on the sire and the dam and all the cousins and so on and so forth.
Thanks, Wade. So we've got an example here that we can talk about. So bull A has progeny represented in this bell-shaped curve with the black stars, and he has a weaning weight EPD of 60. So on average, his progeny, well, let me back up and say bull B here is the second bell-shaped curve with the red dots. And so if we compare bull A to bull B progeny, on average, bull B's progeny will weigh 10 pounds more at weaning. But what we can't tell you is that every calf from bull B will be heavier than every calf from bull A. And so what happens with these traits is you get variation around an average, and so you will have some of bull A's progeny that inherited. They got the lucky card deal, right? They got the best of those DNA markers, and they're going to grow better and or grow faster and have more of a genetic tendency for growth. And you will have some of the bull B's progeny who didn't get a good deal from that shuffling of the genes. And so you can have animals with progeny that don't exactly match up to what we're saying with the EPDs, but that doesn't mean that the EPDs are wrong. That's the biology of what we're working with. And so I guess to answer our own question here, true or false, both B's calves will always weigh more at weaning than both A's calves. And I hope you can see from this graph that that's not always the case. So we wanted to talk a little bit about percentile rank, because that's a really useful number when you're looking at EPDs. And so on herd book, if you look at an animal's EPDs, you'll see 3 lines, and the top one is their EPD for that trait. The next one is their accuracy for that trait, which we'll get into in a little bit. And the bottom one is their percentile for that trait. So the lower the number, the better or more competitive that animal is within that population. So if a bull is, with this example, a bull is in the top 20th percentile for weaning weight. This bottom number here for weaning is 20. That means, he's better than 80% of the rest of the bulls or animals in that breed population. So that's a really quick way to take a look at an animal's EPDs and assess where they lie without actually having to know, well, geez, what does a 71 weaning weight EPD really mean? So this was from last year's percentile table, but you can find the same for this year. And it's on herd book, and what you'll see is the traits going across the top and the percentiles going across the far left. And so for weaning weight, if you looked up the 20th percentile, you can find that number is 69.9. So if you had a certain trait that you knew you needed to make some progress in, you could come in here and select, a certain threshold that you wanted to maintain. Although we'll get into selection indexes here in a little bit, and you'll see that might not be the best route. So we want to talk a little bit about accuracy. Accuracy is another important number when we're talking about EPDs, and it represents how close the estimated progeny difference that you're looking at, how basically our confidence in how much that EPD could move with additional information. So it ranges from 0 to 1. It is the BIF accuracy that we report online is different than an accuracy you might read about in a statistics book. We are not going to get into what those differences are, but you'll hear people talk about BIF accuracy, and it just gets adjusted a little bit for the accuracy associated with EPDs. But anyways, it's affected by the number of records that we have on an animal, the relationship of where the animal with those records in relationship to the animal whose EPD we're looking at, and a number of other things like genomics can influence accuracy. So a nice way to think about accuracy is to actually think about possible change associated with that EPD. And so the next series of slides will just walk us through some different bulls with different accuracies and what we expect the possible change to be with those accuracies. So if we're looking at a calving ease EPD, and again, this possible change table is published in herd book, and so you all can have access to it. So if we look at calving ease EPD, and this bull has a 15, a calving ease EPD of 15 and an accuracy of 0.2. The possible, we look up at this table, we find calving ease, and we find that at an accuracy of 0.2, the possible change is 6.2. So what that means is that 2/3 of the time, that bull's EPD, or true breeding value, lands somewhere in the range of 15 plus or minus 2. So that possible change, or that range, would be 8.8 and 21.2. If we take a bull with a lower calving ease, same accuracy, that possible change is the same. So the range ends up being between 3.8 and 16.2 of his true breeding value. We're always in search of the true breeding value, but these are predictions, and so we will always be searching for it. And even with bulls with an accuracy of 90, you can see that there's still some room for traits to move.
Yeah, and I think I'd like to add one thing to that. So as Jackie said, the possible change covers 2/3 of the time the true value will lie somewhere plus or minus that possible change. But that also means by default that 1/3 of the time it will actually lie outside of that range. And so when breeders look at an animal that might have started out with a very favorable EPD for some trait, and they say, well, wow, it moved way beyond the possible change. Well, yes, that does and can happen. But 1/3 of the time, in fact, an animal will move more than what the possible change range has said.
Yep, that's a good point. Thanks, Wade. So another example of kind of struggling through this possible change and having a gut feel for what accuracy means. If we have that same bull with a 15 calving ease EPD and an accuracy of 0.2, again, the possible change is 6.2, so the range is that same 8.8 to 21.2. Now let's think about having a bull that has a higher accuracy. So his accuracy is 0.6. We come up to this possible change table, and we find that 3.1 is the possible change. So we would expect 2/3 of the time that bull's true breeding value will be in 15.0 plus or minus 3.1, so a range between 11.9 and 18.1. And then this bull E here is a high accuracy bull with 0.9 accuracy. His possible change is 0.8. So the range that you would expect his true breeding value to land in would be between 14.2 and 15.8. So what you can see is if you're using a young bull, you're going to see a wide range here of where that EPD might land. Then a bull that's a high accuracy sire, he's got lots of calving ease scores. His range we would expect to be between 14.2 and 15.8. But one of the things to note here is that this young sire has really an opportunity to be up in the 20s for calving ease EPD, and that older proven sire, while you might not have as many surprises, you're also probably not going to see his EPD get much beyond the 15, 16 mark.
I have a question, Jackie.
Yes.
Cody wants to know, how do you make the possible change table? Wade?
The possible change table is based on what we call population parameters. So the genetic variance, we come up with an estimate for the genetic variance in all of the traits. And possible change is tied to the genetic variance. So if you have a trait with lots of genetic variance, you'll tend to have more possible change. You have a trait with smaller genetic variance, will have less possible change. But it's tied to knowing, and we actually have calculations that we use to come up with an estimate for genetic variance, and that's how we arrive at possible change.
Good.
Good
Good
question.
questions, guys. Keep them
Yeah. Okay, so the last point I wanted to make here with accuracy is one thing that we come across quite a bit, and in particular with the Carcass Merit Program, where we're trying to test a bunch of young sires. And I'm sure you guys may be faced with this, or your families may be faced with this. If you're using a bull battery of low accuracy sires, you're actually going to see a benefit in that scenario as far as not as much risk associated with those low sires. So if we have a bull battery of 4 bulls, all with the same calving ease EPD, and all with the same accuracy of 0.2. So going back to our very first example, possible change is 6.2, so the range would end up between 8.8 and 21.2. But because you're using 4 bulls with that same calving ease EPD, as a group, you can actually divide that possible change by 4. And so as a group, you would expect their EPDs to land somewhere between 13.4 and 16.5. So it's actually a nice way of being able to test some young genetics and find, those superstars, but without having too much risk in getting a whole bunch of calving ease problems.
Yeah, Jackie makes a very good point there, and so if you're going to use young bulls, and frankly, if you want to make maximum genetic progress, you probably need to be using young bulls. But if you do use young bulls, you want to use a basket of young bulls. You don't want to bet the farm on one young bull, because as you can see, the possible change is huge on one individual bull. And yeah, it's great if you use that one bull and it turns out to be, on the upside for possible change, but there's just as good of a chance of it going to the downside. But as Jackie has pointed out, if you use a basket of young bulls, if you use a number of young bulls, you're going to get roughly the average of that basket of bulls. And as long as you're selecting high value young bulls, you're going to do fine.
So wanted to take a little bit of time to just briefly cover genomics, although we might move through this a little quick so that we can concentrate on selection indexes. But really, so what genomics can buy you is time. There's nothing magical about genomics testing, but what genomics can do is get to a more accurate EPD at an earlier stage in an animal's life. And so an animal starts off as their EPD would be an estimate or an average, basically, of the sire and dam for that trait. But we all, or hopefully you all, have an understanding that through the random shuffling of DNA that goes on with every production of a new individual, their true EPD might land to the left or to the right of that average. And so I might not go through this just in the interest of time. So adding a genomics test is like adding, 15 to 20 progeny records for a number of traits, although the carcass traits are a bit lower. But adding a genomics test is like adding 15 calving ease scores to what we know about an individual's EPD. So it just gets to that point, or it gets to a higher accuracy level earlier in an animal's life.
I think one thing I'd like to add quickly to that last slide. So as you can see, on a young animal, having the advantage of 15 progeny or 22 for calving ease and 22 for weaning weight and so forth, that certainly gives you a leg up. And and you can put more faith in that EPD, and that possible change is going to shrink down. But it also points out that it is not a silver bullet. The thought amongst some in the past especially was that, boy, if it has genomically enhanced EPDs, that's the cat's meow. You can't, I mean, you can bet the farm on that. Well, no, you can't. It does increase the accuracy, but no one would bet the farm on a bull that had 24 weaning weights or 24 yearling weights and 22 weaning weights. That's not enough animals to have an accuracy where you would bet the farm on it. So that's something to keep in mind. It's not a silver bullet, and this is a very good way to look at it. It's just like adding additional progeny, and though 15 to 20 calves on a young sire is wonderful, it's not the silver bullet that some thought at one time.
And the other thing along with that is people can't stop submitting phenotypes. The reason why genomics work and will continue to work is that we have phenotypes associated with these animals as well.
The numbers you see here, if you stop submitting phenotypes, those numbers would start to go down with each generation. And so we need to continue. In fact, the reason when Jackie mentioned that the carcass equivalents are not nearly as high as the growth, and that's because we don't have nearly as many animals with carcass data and phenotypes in our database, and we are working on that right now. Your board of trustees has allocated a substantial resource amount of money towards rounding up more carcass data and genotypes. So those numbers should be increasing over time, those carcass numbers especially.
And what's cool is all of your animals will have carcass and genomics, which is great.
So you guys are going to be part of increasing those numbers. So all of those SPC steers are going to be added to that database as well.
Yeah, you can own it. Own it with pride.
That's right.
All right. So one question we've heard is that, somebody might not believe in DNA tests because their best bull out of their best genetics had EPDs that got worse after genomics. So what would you say to that argument, Wade? Will EPDs always improve?
Unfortunately, the only thing I can guarantee you, or we can guarantee you, is that the accuracy will improve. We cannot guarantee that the EPD will improve. In fact, we can guarantee that roughly half the time it will go down. The other half it will go up. We can guarantee that. And that's the same as with phenotypes. As you add more phenotypes, more records, more birth weights, weaning weights, yearling weights, as you add more records to a sire's or an animal's to the database, an animal's accuracy will go up, but there's always just as good of a chance of its EPD going down as up.
Thanks, Wade. And, I guess one step further, if we could predict that they always went in one direction, then there's bias in the system.
Right.
We want it to be.
Yeah, at any one point, that EPD is the best prediction possible given the information we have on that animal. And as Jackie said, if that was routinely, if we could do better, you're basically saying that, well, gee, that should be higher or lower. We know it should be higher or lower. If that's the case, there's a bias, and we're not doing the best job we can of making that prediction.
So, yeah, and I think this just drives home that point. Again, there would be animals with good and bad DNA, and we don't really know what that is until later on in life or until after a DNA test. And so, anyway, we wanted to spend the last, 10 minutes on selection indexes and decision support. And again, this will be the tip of the iceberg, but wanted to at least have some time to visit with you about this. So there is an increasing list of EPDs and other data that's being published in sale catalogs and things like that. And I think what we're starting to see is decision fatigue when it comes to trying to pick who's the best animal out of all those pieces of information. And so really a helpful area in genetic evaluation is to try and provide some decision support tools or some easy to use pieces of information that help people make genetic selections reliably and make some improvements there. So knowing which trait to emphasize is difficult, and if you select on any one trait, you might have unfavorable outcomes on other traits. And so that's really at the heart of economic selection indexes. So an economic index combines EPDs for economically relevant traits, those traits that influence the profitability of different sectors of the beef industry. And it assigns costs and prices associated with those traits to come up with one number that predicts profit. So the ASA has two economic indexes. They are the all-purpose index, which is best to use if a portion of your females will be maintained as replacement heifers and go on into the cow herd. And then there's the terminal index that assumes all calves will be harvested. So API, or the all-purpose index, doesn't ignore the terminal calves. It assumes the steer calves and a proportion of the heifers will be harvested. But in the terminal index, the maternal traits, you can largely ignore except for having a live calf because those females are not going into the cow herd production. So this graphic was developed by Tim Cartledge with Lancaster Black Simmentals in Australia, and it nicely depicts API and the traits that influence this index. And so the way these indexes work is by creating an entire beef cycle and looking at all the traits that influence profit, all the input traits that would influence the expenses, and all the output traits which would influence the income for the cow-calf unit, the feedlot unit, and the packing plants or the abattoir. And then we also need to add how much of an impact each one of those traits has on profitability. So they get weighted according to how much movement in that EPD will adjust the profitability of those operations. So one thing that we hear routinely, Wade, is that selection indexes don't put any emphasis on growth. Could you address that with our group?
Yeah, and I think that's probably more of a belief held about the API index. I can tell you that when it comes to the feedlot and growth to weaning, and in the feedlot, it puts the same weighting on growth. API puts the same weighting on growth as TI. However, as Jackie said, TI is confined to growth to weaning and then feedlot growth and carcass traits, whereas the all-purpose index affects all the traits, or accounts for all the traits that affect profit in an integrated production system. So it also takes into consideration the cow herd traits. And when you take into consideration the cow herd traits, what ends up happening is several of them, specifically stayability, or a couple of them, particularly stayability and cow herd intake, how much your cows are going to eat, they tend to trump growth. And so, yes, it's still, the API index does weight growth favorably, And there certainly are high growth cattle that are also high API cattle. But it does, because it also takes into consideration cow herd traits, because you're keeping replacement females, and those traits have a major impact on profit. I mean, we've known for many, many years that fertility trumps all else in an integrated production system. Because of that, you'll find cattle that are very much on the low end of the totem pole for growth, yet they rank very high for API because they excel in cow herd traits.
Thanks, Wade. So another question that we hear, or misconception that we hear, is that single trait selection is bad. So producers should not focus solely on a selection index. What would you say to something like that, Wade?
Well, I would start out by saying, so I've got a friend that will say, it's okay to select for a single trait as long as that single trait is profit. And that kind of sums up why it's fine to select for a single number, the index value, to use the index value for selection. And I'm not advocating, if you're a seed stock breeder, that's all you pay attention to, because there are all kinds of other factors that affect the marketability of cattle, their color, their pulled horn, disposition, and so on and so forth. But there is, to call selecting on indexes single trait selection is very inaccurate. It in fact simultaneously selects on all traits that affect the bottom line. So it is the antithesis of single trait selection. And yes, it is a single number, but at the end of the day, that single number has factored in every trait that affects profit in a production system. So it is not single trait selection by any means.
Thanks, Wade. So to wrap up the selection index discussion, I'd like to point you guys to a talk that Matt Spangler gave at the Fall Focus in 2018. That's available on the Fall Focus website, which we list at the end of this talk. But he talked about a number of things that would be great for you to hear about how to get the most out of a genetic evaluation, and how breeders can help drive where we're going. And one of the things he said was that a picture is worth 1,000 words. And his very next slide says, but it only takes two, API and TI. And so I think, again, we can create decision fatigue by providing all kinds of information on an individual animal to a point where people don't know even what to look at anymore. But we can really boil it down to these indexes. They do a very nice, robust job of estimating profitability of those genetics. And so I encourage you all to check out Matt's talk. It was very effective.
And I would add to what Jackie said, that yes, in the beef cattle breeding world, they are relatively new. We've had ours, I don't know, 12, 13 years probably. We were one of the first to introduce indexes in our industry. But first of all, the concept, the economic selection index, the theory was developed by a guy named Lanoy Hazel way back in 1954. The paper was published, and soon after that, the poultry industry adopted it. The pig industry came not too far after that, and the dairy industry followed. And so we're kind of late to the game here, but there is no question in the world of animal breeding among geneticists that if you want to maximize profit via genetics, you need to be using selection indexes.
Okay, so final question for the night, Wade, and this is something that we hear quite a bit, but beef cattle are raised in various environments, so how can you have an EPD or a selection that works across all these environments across our country and across our world.
Yeah, and that's I think a very commonly held perception. There is some merit in thinking about those kind of things. We have a one-size-fits-all index. Now, interesting enough is we find that indexes, even when applied across environments, tend to be quite robust. They might not fit exactly right. In your particular situation, you might be selling your calves at weaning if you're a commercial producer, and in those cases, maybe marbling isn't worth much. Although in an ideal world, if you don't have good marbling cattle, even if you're selling them at weaning, you're going to get discounted, and that we're moving more and more towards that. So in general, and we've looked at these things across many different environments and even different, not only biological environments, economic environments. I used to use an index that was developed in Australia. And yes, they have different pricing, costs and prices for their products and their inputs and so forth. Yet, surprisingly enough, it still ranks cattle, even that Australian index still ranks cattle pretty well, and so pretty accurately. So the thought that, hey, these things are, it doesn't fit my situation, so I'm just going to ignore it. I think ignore at your own peril, because they are robust and they certainly will rank, maybe not exactly perfectly across the entire country, but they do a pretty darn good job, and they are quite robust.
Thanks, Wade. So I guess to wrap this up, and then we'll spend a little bit of time talking about your next assignment. Really, EPDs are the most accurate way to select for qualitative traits. 7 to 9 times more accurate than phenotypes, looking at actual phenotypes for those traits. Genomics, there's nothing magical about it. It just adds information, more information than you can at a young animal's life by just one simple DNA test. Economic selection indexes select for profit. They are simple, and they're really the best tools available out to make genetic progress for profit. These tools are easy to use and readily accessible, so I really hope that all of you that are involved in this program are taking advantage of the wealth of information that's available there. With that, we've got some resources that you can dig into when you have time. Our website has a number of different articles, documents on different things. fallfocus.org, there's an archive of all past meetings that we've done, and there's also Fall Focus coming up this summer. If anybody's in the Kansas area, we'd love to have you at the Fall Focus. ebeef.org is another great resource for animal breeding and genetics in beef cattle. And so with that, here's your assignment. We would like, Rachel, you want to talk about it?
Absolutely, you bet. All right, you guys, so here's what we're going to do. So our assignment for January is for each of you to create your own selection index. So the first step that I want you to do is to describe your operation and animals. So that can be anything you want it to be. You can make something up if you want. That's totally fine. So describe your operation and your animals. And then the second thing I want you to do is tell us the 3 most important traits to you in selecting animals for this operation that you've described in part 1, and why those are the 3 most important to you. And then the next step is to take the next 3 most important. So 6 total, the 3 most important, and then the 3 next most important traits. And so we'll hopefully in February then have some time at the start of our webinar maybe to review a few things and talk a little bit about what you all decided. Remember that I know what age division you're in, and so I will keep that in mind. I know some of you have been worried about rubrics in the past. I have a rubric, a scoring sheet that I'm going to use when I read through these. I'm going to email that out to all of you so you can see how I'm going to assess each of your your selection indexes. And so basically you can just email that once you get those complete to the SPC email, and those will be due 1 week from tonight, Tuesday the 15th at 6 p.m. Mountain Time. Any questions in the meantime? So unlike Jackie said, since we had a few technical difficulties off the top, I'll also email out the slides to you so you can take a look at those ones at the beginning that you couldn't see.
Sorry,
We'll
pictures
try,
of me in my youth.
we'll try harder to be technologically advanced next month. So that said, I'm not seeing any questions. So the next webinar will be Tuesday, February 5th. We don't know what the topic will be yet, so that's to be determined. But you'll get your newsletter probably the last week of the month here in January for February. And here pretty soon, I'm sure I'll hear from Chip with some up-to-date weights and some billing information. And so we'll get the bills out for the December time period. So with that, thanks everybody for being on, and we hope you have a good evening, and we'll talk to you next month.
Thank you, guys.
Take care, everybody.